Okay, so guys, the last time I reviewed shapes and I thought I would do a tutorial this time since there doesn't seem to be much out there on the net. So let's have a look. So I'm going to get started off with the sine wave, show you how that is done. And then moving on from that, I'm going to show you how to move this dot in a circle. So just some basic math there with sine and cosine and how to create this little dancing circle thing. And this one as well. They're all quite similar, but you'll get a good idea on how to create your own effects after this. The next one I will be looking at is creating a health bar. So this over here, when you click, it just simulates your health moving down, and that's a cool little animation I've got there. And then next is this radar. This radar was pretty cool to do, nice and easy, and I think really shows the true power of shapes. Then the last one is this little animation I created, and it's just done with some rings and disk and just the Unity's animation tool. So no code in that one. Let's see how this is done. I'm going to show you how each of these is created with shapes, but first let's go over some basic math. I'm going to do a very quick overview of what the sine and cosine graphs look like, as well as how to create a circle with these functions. If you're comfortable with this type of math already, you can skip over it to the next section. The first thing I want to talk about is radians, because Unity's math functions for cosine and sine take in radians. A radian is just another way to measure an angle. Let's have a look at how this works. So if I go into Unity, I was going to do this demo using some other software, but I figured why not just use shapes for this. So I took Cartesian plane. So Y is going top to bottom in green, X left to right in red, and then I've just got a circle over here. So a radius of a circle, as you all know, is from the origin till the diameter, so about that big. In this case, a radian is the length of that radius put around the circle. This is what 1 radian would look like for this specific circle, and you'll see I've got it set up here. So using the arc tool, so disk, arc, and you can see here we have a radius which you put in, which is the same as the radius here for this line. See the X line here is from -5 to 5, so radius is 5. Going back to this arc, I set the radius to 5. Angle start to 0, so that's starting from 0 over here, going counterclockwise. See, that goes counterclockwise. If I set it to 1, that's 1 radius. And this length here of this arc is the same as the length of your radius, and that's radian. So let's see, going around that circle, I want to show you something special. So you'll see we are reaching half a circle and approaching 3 radians over here. You'll see we're just a bit over 3 to get to that half a circle, and what is that full value we need? It's actually 3.14. Sound familiar? That is pi. 3.14 radians, or pi radians, is half a circle, which means 2 pi radians is a full circle. We will get to that later. For our next example, I'm going to show you what cosine does. Okay, so we have sine and cosine. I'm just going to press play because I created a script for this. And here we have a dot on our x-axis. I'm only incrementing x in this case, and I'm incrementing it by the cosine function. Actually, the degrees is incrementing. So you'll see here, if I click on my script, I've got this angle. The angle is currently set to 0, which is why it's over here. As I increase that, it moves off to the left until it reaches a point. That point is 3.14, and I actually stopped right at 3.14. If I move past 3.14, it starts going back to where it started from until I reach 6.28, and that is the maximum. So we can continue increasing this value, and it will just loop through as if it was just going between 0 and 6.28. Okay, but as you're increasing, it's like going multiple times around that circle. You'll see even the animation plays a bit slowly towards the end, almost like it's orbiting something, right? I'm going to change it back to 0 because the next example I want to show you is sine. And sine, I've set it up to move along the y-axis. So let's increment that value again. You can see the values here for x and y and my radians. And you can see that, like if you just look at y, for example, you see that's just past 0, going up to 1, 2, then coming back down to 0, going down to -2. I don't know if you guys can see anything special about the way these two dots are moving. It's done on autoplay because I can help you by putting these lines together. If you look at the corner, does that look like anything? How about now? Look at that blue dot, it's just moving in a circle. So if I change X by applying cosine to that angle, and Y by applying sine to that angle, I get a movement in a circle. Okay, so now we can get onto our actual tutorials. The next thing we are looking at is how to create the sine wave in Unity. Okay, I've gone ahead and created a new scene for my sine wave, and I've created a new script. At the top of your script, just add in using shapes to import that namespace, and then instead of extending mono behavior, you are going to extend immediate mode shape drawer, and then extend this method. Override this method, draw shapes exactly as is, and add in this command using draw.command. So shapes renders directly on the camera. Okay, so it works using the on camera pre-render. Just let me have a look here. On camera pre-render method, so you don't have to go and do all this pre-setup by yourself. You just extend this class, extend draw shapes, and then you're good and ready to go. If you want more info on how this all works, you can read the documentation online. And okay, let's see now. There's some more setup we need to do here, and you'll see that this, yeah, it's quite basic, and you'll use the same commands most of the time, I found. Okay, so draw Z test, it just handles your depth properly, and I just realized I forgot to import something, and that is Unity engine.rendering, which is why it's not finding this compare function. So I'm just gonna plunk that in there using Unity engine.rendering. Okay, blend mode. That's if two shapes are on top of each other and transparent, then it will decide how to blend them together. It works much like a drawing application does, like Photoshop or GIMP or whatever it is. Line geometry, there's flat 2D, depends on the actual shapes you are drawing. Okay, draw matrix. This is basically saying that we are going to draw everything on the local transform relative to whatever this is, and I'm going to show you what that means. So if I go and create a new object here and I add my sine wave over here, it's going to draw wherever this transform is. Okay, relative to that, so just your basic local space. And now let's stress it out. I'm just going to do a simple circle, which is it circle? No, disk. And you'll see there's a bunch of overloads. If you want to see what they all are, just control click on that, and then you can see or try to find the exact one that you want. Because I find that Visual Studio's autocomplete gets a bit confused. So let's see, I'm just gonna go with the simple one, just with the radius. I'm gonna set it to 0.2. Okay, now let's see if that works fine. Okay, there's my little ellipse or disk. It's quite small. You see if I move this, it draws it relative to this transform because I've set it to local space. Okay, so that's looking good. So far so good. Okay, now we want to get the sine wave, and to get that right, firstly let's make this a variable. I'm just gonna make everything public and not add in serialized fields all over the place, just to keep this code a bit more concise. Okay, so I'll call it disk radius, and I'll add one for color. Float movement radius. Cool. Now this draw command gets executed every single frame, and what I'm going to do is just set up a couple more variables, one for x and one for Well, actually, I think just x should be fine. So let's go ahead and add that in. We're going to make you private. Okay. So what we're going to do here is increase x with every frame. So we'll say x plus equals 0.01f, because that will increase quite dramatically. So we want to just make that a bit slow. Actually, let's make it 0.05. See if we get that to move. Okay, so we have draw disk. You're gonna make that draw at a specific position. So x 0, 0. And we have disk radius. Close that bracket off. Okay, disk radius. And color. Cool. Test it out quickly. So you can see we've got color here. So let's make that red. Disk radius will make that 0.2 or 3, and movement radius will make that 2. Something you need to keep in mind is that when you add a color field, it sets its transparency down to 0 completely. So just make sure that's up to 1. And now this should work. Okay, we have our ball moving across to the right. Not very exciting, but we're going to change that now. Before we proceed any further, I want to show you what this looks like when we just using the sine function on one axis. I'm creating other variables here. One for the y-axis and another one for the angle. So we need an angle that we want to increment, or this is not going to do, there's not going to be any motion. X, I'm going to comment this out so that x stays constant. We are just going to increment y or change y by sine. Math.sine. And we're passing that angle, and we are going to multiply that by the movement radius. That's to increase the length of that radius. So we need y over here. And then we need to increment the angle after every iteration. 0.01f. I'm going to increase that disk radius quickly to 0.5, and movement radius I made it 6 so that we can see that movement a little easier. Okay, so that's moving up and down, straight up and down. But something I want you to notice is that as it gets to the top or the bottom, it slows down a bit. You can see it better if it's a bit bigger. I'm sure you can definitely notice a bit of a slowdown there. Let me just change this value here. Let's make this 0.005. Okay, that's a lot easier to see. So that's going fast, and then it slows down at its zenith and at the bottom. So that's basically what the sine function does. It increases, and then until it reaches a point, then goes in the opposite direction until it reaches the opposite point, and continues like that. Now to get it showing a nice sine wave, all we need to do is add in x again. So x we're just incrementing at a constant rate. So that's going to move flat, but that y value is moving up and down. Remember, as it reaches the top, it slows down a bit, so that's why we get those curves. So let's see what this looks like, and there we go. That's curving to the right, up and down, and that's your sine wave. Cosine wave is exactly the same, except it's a bit to the right. So what I'm going to do here, I'm going to call this y1. Let's really move that value over there. I'm just going to move code around a bit just to neaten things up. I should ideally move this to a method, but whatever. Just showing you guys what this does. So cosine. Cosine is exactly the same as sine, except it's a bit shifted. So this needs to be 1 and this is 2, and so you'll see this will draw 2 discs. Both follow the same shape, but the one will be a bit shifted. So let's see if we can see what that looks like. I'm going to change this color to just red. I'm not creating another variable because I'm going to remove this after this. So it's the same shape, except the one is a bit up. And let me show you what the diagram looks. So if I do a quick Google search, you can see easily what's happening here. So I just search for sine cos wave, go into images, and you can see just by clicking on one of them. So the red one is your sine wave, and then your cosine wave is the blue one here in this case. Exactly the same shape, except your cosine wave is a bit shifted. So that will go through the origin, whereas your sine wave does not go through the origin. And that's that for this example. And now we are going to get a circle to move around in a circle. I just duplicated my scene and called it spinning circle, and I renamed my new script to the same thing. Okay, so this is the exact same code that we had last time. I just copied and pasted basically, and we are going to update this. So this part at the bottom can come out, and I need a value for x. Okay, so x and y, that doesn't need to be y1 anymore. And to get a circular motion, this is all you need to do. For your x, I can remove this x over here, since we're recalculating it every single time. So we need to get the cosine value for x and then the sine value for y. And that is how we are going to make this object move in a circle. That is all there is to it. So if I go back now and that script in, I'm going to make this 6. Oh, whoops, this should be something like 0.5. And this color will be transparent, so need to ramp that up. And there we go. We have a circular motion. It's moving counterclockwise, so to get it to move clockwise, we can just decrease that angle every single time. Remember, this is using radians, so radians will move counterclockwise. Here's your adding. So there we go. That's moving clockwise, and that was easy enough. This is the one we're doing next, but we'll get it to spin around the y-axis as well, like that. So the first thing we'll do is get the circular shape. Okay, so you can see it's along the XZ plane. Let's get that working firstly, and then we will add in the motion for moving it up and down on the y-axis. Okay, I created a new scene, a new script, and I've cleaned up everything except what we need. So we've got our using draw command here and just setting up our draw calls. That's going to be pretty standard going forward. I've added in a variable for the number of circles, since this year we will dynamically generate the circles. It's not just going to be one, so we'll enter how many circles to be generated from the Unity editor. We need to keep track of the y coordinates. Before we do that, let's just generate the actual circles. So we need a for loop here. Okay, we are going to set up our x and y variables. X and z actually, since we are working off the z plane. So to calculate the angle for each one of these, what we need to do is get tau. So tau is basically pi times 2. That's a constant I'm going to create over here. And that is in radians, basically the full circumference of the circle. So because we are working in radians, that is quite important. And what this is doing is taking that full circumference, so pi times 2, which is 6.28, thereabouts, dividing it by the number of circles, and then by I will give us the index along that circle, giving us equally distant number of circles that will be generated. So we have our xy coordinates. Let's just draw our sphere here. Okay, we've got color set up already. X, Y will be 0 for now. and Z. So if we press play, this will generate black circles. Just adjust the camera quickly. In play mode, here's a nice tip. So I can move this up and down. Let's put it at the bottom like that. And because I'm in play mode, this is obviously going to reset when I stop. So what I can do is click on these three dots on my transform, copy component, stop, click on those dots again, and paste component values, and that will take me back to what that value was when I had play initially. So you can see when I press play, those values are there, and just as I had them when I previously was in play mode. Going back to this animation, what we need to do next is get the form of the sine wave going around that circle. So the sine wave is basically the y-axis that we're interested in this case. That's going to be moving up and down. So let's get back to that script and see what's up. We are going to create an array for the y values, and the reason for that is to initialize it on await. So here I am initializing it with the array with the number of circles, looping through that and just giving it a sine value. The reason I'm adding 1 here is because, well, it starts from 0 and sine of 0 is going to just be 0, and that's going to give that very first element no movement. So that's why I added 1 to it. And over here, instead of 0, I'm going to put in yi. That should generate the shape of the sine wave. Great. Let's increase this to 7 and number of circles to 50. Okay, you can see this, the form of that a lot better. There we go. Nice sine wave moving around that circle. Now we need to add the movement in to get it to animate nicely. And for that, we are going to do this. Create a new variable. I'm calling it y underscore, so it doesn't conflict with my array. So in this case, I will replace that. So we are changing that sine value over time. This 5 is hard-coded. I'm just going to leave that. So this is going to determine how this thing animates over time. Okay, time to time is the time from when you first press play, and that will get that animation going, and you're multiplying it. So this here is going to give you the distance or the range of motion. So that's where this is so important, to initialize that array with its proper sine value, so that this here now, whatever that value is initialized to, that's going to be the maximum range of motion that that specific circle is going to have given its position in that array. If we press play now, you see, so for example, this ball over here, its range of motion is very low, whereas the one next to it is higher. And that's why we multiply by that y value. Okay, now what can we do about the colors? Let's see. We want to change the color depending on its I value, I guess. This is some code I got from one of Freya's classes. That's the author of shapes. And what this is doing is just taking the current angle divided by the number of circles, and that's the hue. Saturation I'm leaving at 1 and value leaving at 1, so it's just the actual hue that's being changed. And if you press play now, it's going to give it a different color all around. Great. Now we need to get it to move in a circle, so get the whole thing to rotate around that y-axis, and for that I'm adding a variable called angle increment, and after the for loop I'm going to increment that by 0.001 f, and this here at the moment as it is, we are creating or calculating that angle based on its position or the number of circles, okay? And depending on the index of I. So to get it to now rotate, we need to just add in that angle inc. So add in angle inc there and there. So for X and Z. And now I should get that rotating around the circle. Cool. Awesome. So you can see what can be done with the sine and cosine functions. Some very cool animations. And if you dive into doing shaders, you will find that sine and cosine are used all over the place. So enough of that now though. Let's have a look at how to do that health bar. Shapes is actually perfect for doing your heads up displays. So a health bar is a very good example of something you would use shapes for. So I created 3 variables. One is your current health, then your health bar width and height, so that you can adjust it to your liking. And everything is set up as before. And I've gone and created this rect. Okay, so this is a struct that will determine the actual bounds for your rectangle. This is the outer rectangle, so it will start from 0, 0, your health bar width, health bar height. Straightforward. And then to actually draw it, we are going to use draw rectangle border. So draw.rectangle border, we pass in the outer rect. Line thickness, we can pass in this corner radii, which I'm going to do in a second. But let's see how this looks. Okay, there we go. That's our rectangle. I'm going to change the background for my main camera to solid color so we can see that a bit easier. Now let's say in that corner radii, that's going to give it a little slope on the top right hand corner. And I'll show you how this works. We are going to create a vector 4. And each one of these, starting from the bottom left hand corner, will determine the slope of your corner. Okay, so I'm gonna give these different values. So that's our 0.5, 1, 1.5, and 2. And we'll see the difference that this makes. Okay, so you can pass in corner radii just before border color. And now if you go and press play, we'll see this is gonna be a rounded rectangle. Okay, this is 0.5, this is 1, this is 1.5, and this is 2. I'm going to use 2 for that top right hand corner. So that's the third argument. The rest I'm going to set back to 0. I went and pressed something by mistake. Okay. I'm going to set all of these to 0. Except for the top right hand corner, which is this argument, the third argument, and I'm going to set that to 1, and the last one will be 0. Actually, let's make that 2. I think that's what I had previously, so let's see if this works. Okay, so that's 0, 1, third argument is that. That looks quite nice for a health bar. Now we need to get this thing filled, and for that, I'm going to create another rect for my inner rectangle, and we need to work out the health percentage. The health percentage is basically just going to scale that properly. I'm going to put this above here. So that's our current health multiplied by health bar width over 100 to give us a percentage. So that's going to be our inner rectangle, and this is going to be filled. So we're going to draw this first and then draw the border on top of that. So the order is important here. Okay, this is a long one. So the important parts are this inner rect, corner radii, so it matches the outer one. This here, the shape fill, create linear, is basically going to create a gradient for us. So you can mess around with this. It's actually this whole thing, if I'm not mistaken. So yeah, this shape fill, create linear, is all the way till the end here, this whole thing. So this just creates a gradient, and it's going to create a linear gradient from 0 to the right. We have got health width percentage. I've got my full color start, full color end. These are variables I've created on top, which we are going to set from the editor, and full space local. That's just for, yeah, well, that's obvious. So let's see what this looks like. Brilliant. Okay, so I went ahead and set the colors. You again just make sure this alpha is set to full. I made it black. We can make this a bit darker red, I think, so we can see the gradient a bit better. Make that from pink to red. Cool. And that's a very basic health bar, and that's just how you draw it. If you want to see me add in the rest of the script where it goes down, that health goes down whenever I click on the mouse button, then stick around. Otherwise you can skip through to the next section where I'm doing the radar. So it's a nice one, and a nice quick one at that. I'm going to add in a click handler, so that means an update method and just some basic checks. So yeah, I'm just checking that the health doesn't go below 0, or if it is less than or equal to 0, then just skip everything and don't do anything else. Check if the mouse clicked, and subtract 10 from the current health. So if I press play, that should now decrease. Okay, so you can see the animations don't look all that great. The color's not great either. Let's just change that. Red and somewhere along there. Okay, that looks better. So what I'm going to do is get it to animate slowly, because that just snaps away 10 every single time. So I'm going to create a new method in a coroutine. Start coroutine, shot. Private IE numerator shot. So in here we are going to gradually decrease that value. So we have current health subtracted. Let me just think a bit. So we want to go from the current health downwards. So let's not do that over here. What I'm going to do is create some temporary variables. So health, and that's going to be the current health. I have plans for this, so just bear with me. That's why I created another variable for that. So new health is the health value we are going to. So that's going to be health minus 10. Okay, I'm just hard coding that. You'll definitely want to have that as a variable or a parameter passed in or something. We want to go down slowly. So I think a for loop. Let's make it go 30 times. And 0.1f, I guess. Well, let's make it 1 second over. Let's create a variable here, and index equals 30. So 1 over index. To index. Okay, so now of our actual health, we want to do a loop. Okay, so we have health, we have new health. So we're going from our current health down to new health and looping. That's our t value. So that's going to be a value of I over to index. So as I increases, it will move towards 1. Okay, so let's see what this looks like. We need to set our current health as well, because that's not going to change otherwise. Too fast. Let's make you cool. You can see it animating better. If we make that 100, it'll still be better still. And you can see that sliding along nicely, nice and slowly. Okay, great. Another effect I added was to make that health bar flash white. We need 2 variables to hold the actual full colors. Okay, so this is gonna just store these variables with these values that we had entered in through the editor. So full color start, we're going to make you color dot white. And the same for end. And then what we can do is just do a loop as well on the colors. So full color start is going to lerp from full color start to full color start. So that's the original color that we had that we entered in through the editors. Remember, full color start now is going to be white, and full color start is going to be red, or the darker shade of red, or whatever it is. And yeah, change it accordingly. So that will flash white as soon as I click, and then go back to the original color. So you can see that. Another effect I added was just to increase that health from the beginning. So I made this go to +5. So that will kick forward and then come down. Like you see, that went past the end there because it's at the end. So you see that kicks forward and then goes down, which gives it a nice effect. So I'm going to stop here. You guys can play around with that a bit more. It's a good base to carry on from. I just want to continue because we're running out of time. This is already getting a bit long. Onto the radar. This turned out to be a lot easier than I initially thought it would be. I've created a new scene in script and created a new game object on which I added my script onto already. So let's see. We've got variables for line thickness, use 3D or not, which I don't think I'm actually going to use. Anyway, let's just leave it in there. Line color start, line color end. Important to have both colors. Border color size will be the size of the actual widget, whatever it is you want to call it, the radar. And angle is going to be increasing. So just how we did it for the circle ones. So these others, this is our basic setup, and now we can get started with our actual implementation. So we are going to use pi gradient angular, and that's going to take in the start angle, and that's going to be the angle of that shape that's moving around. So let me just show you what I mean. Okay, we've got our game object, we've got our two colors set here. I made sure they are not completely transparent. The second one can be semi-transparent. First I'll make sure it's not, so you can see it easy. Okay, so that's the start color, that's the solid one, and adding 1 gives us that arc, and that's adding 1 here. So if I add 2, that's going to be bigger, just to show you what that means. Okay, so that's bigger. So I'm going to leave that at 1, and that color, the second color, I'm going to make that completely transparent. So you can see how that fades. Okay, I'm just using red to be different. Red radar. Now we need to get this thing to move in a circle. So we've got our angle set. That's our start and end angles, and we just need to increase that now. So remember, to go clockwise, we are going to subtract it, and we are going to just use a very small value there, 0.005. Yeah, needed to make sure I had enough zeros there, and that's moving. Okay, so that's the hard part done. The next is just drawing circles, and for that we are going to actually draw rings. So after that, and I'm drawing it as a percentage of the size. So we specify the size up front, and this will get it to scale properly by just using a percentage. So 90%, 70, 50, 30, and 10%. Going to be the size of all those rings. So let's see what that looks like. And I'm using the start color for those. Okay, so we've got those rings. Now, lastly, we're just going to draw a bunch of lines. So from the origin, that's vector 3.0. The origin is where our widget is. So that's our game object here. From here, it's going to draw up, right, down, etc. Multiply by size. Easy enough to follow. And there we go. That's our radar at work. Can change that size. It scales accordingly. You can see each circle also scales properly. So yeah, that's great. Of course, it looks a lot better in green. Oh, that's cool with the red effect. Let's change it down. Yeah, green looks much better. Cool, so that's it for the radar effect. It was nice and quick. This last one I'm going to go through quite quickly. This is not using any coding at all. It's just using the shapes from the user interface and some animations that I set up. I did this one because it's on the examples reel on the asset store, so I wanted to just see if I could figure this out. So if you right click in Unity on the side and go to shapes, you can add a whole bunch of stuff. And what I ended up using was just a bunch of discs, lines, and a triangle. So you can see, for example, if I add in a disc, it just shows up there. You can move it, rotate it, etc. just as normal, and then resize it, change the radius. And then the cool thing here, and I'm going to show you how I did this as an example. With your disk selected in this case, you can go to animation, create, and I'm going to call this test animation. Now here under test animation, you can go and add a property, and you can see you can add a property for any of these attributes under your disk. So I'm going to click on that disk, and let's change color, for example. So I can click on color and animate the color. So I'm going to go click on record, and starting from white at 0, I'm going to move down to half a second and change this a bit. So let's make this 0.5, 0.1, 0.1. Okay, so a nice red, and alpha, let's make you 0.3. That goes transparent as well. So if I press play, there's another keyframe at the end that has it on white again. So that's going from white to transparent red to white again. And that's how you can animate it. It's as simple as that. And that's all I did for this example over here. I just created a bunch of things. So I've got the disk, and under my disk, I've got a bunch of lines. So they all rotate together. And another disk inside. I think what I added here was a bit of a color gradient to make it look like it has a shadow. So that's the gradient there. You can see if I change it, I made it rather subtle. And then these disks, this was hard getting it animated correctly, but yeah, it's still using this animation. And you can see how that moves up and down, and the triangle just moves up and down, straight up and down. And that's it. Combine it all together, you get this nice cool effect. I think all in all, this maybe took me about 15 minutes, but that's because I've been so out of touch with creating my own animations in Unity. So if you're used to doing it, then you can get it done in a few minutes. So yeah, guys, I hope this helped. Shapes is an awesome tool. If you bought it, I hope this helps you guys out who were a bit stuck with it. I have another Asset Store voucher to give away today, and that is for a Nani Novel, which I reviewed not too long ago. So have a look at that if you haven't already. It is a really awesome asset, and let's say I'm going to be using my Wheel of Fortune project again. I haven't updated it, but it worked so well the last time. It was developed in shapes anyway, so it's appropriate. So let's see who the winner is. I've added everyone who's commented on my last couple of videos, as well as public subscribers from my last upload. So let's see who the lucky winner is this time. There are 20 contestants now, and the winner is Suvesh Misra. Congrats, and I will be in touch with you soon to hand over their voucher. Until next time, everyone, enjoy.